All right. Now, this question says, given circle S, circles are named sometimes for their centers, with chords TU, UX, WT, TX, WV, and TV. All that's doing is just describing the diagram. Then it says arc TU is congruent to arc TV. Now, one of the rules we went over, if you take a look at two chords, again, a chord is just a line that connects two parts of a circle. If the chords are congruent, then the arcs that they cut out are congruent. So if arc TU and arc TV, I don't want to make that more confusing. Anyway, equal chords give you equal arcs. So if arc TU, will go down to the real question here. If this and arc TV, those are congruent, then the chords that cut them out also are. So name a segment congruent to TV, TU. And all you got to do is type the letters in, use capitals, or else it'll not mark it right, I think. It makes you use capitals. All right. Okay, given circles N to NO with QTS tangent to N at point Q and to O. So this line is tangent to both. Tangent means it just hits the circle once. It says identify a segment that is congruent to ST. Two tangents drawn to the same point from the same circle are congruent. So here's ST. We got to look at this circle. Tangent to the same point. There's one tangent, the one we're given. There's another tangent to the same point from the same circle. So they are equal. So RT. Again, they just describe the drawing. Here it says arc LM is congruent to arc LN. So that arc and that arc. Now, this is the rule from the problem before. Equal arcs are cut out by equal chords. So those two little lines there, almost on top of the arcs, are congruent as well. So congruent to LN, LM. Identify a segment that is congruent to UW. Well, UW is a tangent. So two tangents to the same point from the same circle are congruent. So WT is what you would type in. Identify a segment that is congruent to LN. Okay, here's LN. It's a tangent. Two tangents drawn to the same point from the same circle are congruent. So that would be KN. All right, now these are a little bit different. On these, we're actually working with some numbers and with some math. Now we have two chords intersecting inside of the circle. we want to find the length of PT, so this one right here, X. Now the formula for this, you just go down a chord, part times the other part, X times 12. Go down the 6 times 25. We write that as 12x. That'll be 150. Divide by 12. You get 12.5. Same rule here, round to the nearest tenth if necessary. We're looking for the length of PR. So there's our X. Again, just go right down the chord, 13 times X, 16 times 15, and then 240 divided by 13. Now on my calculator, I got 18.461538, so on. Says round nearest tenth if necessary. This 6 will bump the 4 up to a 5. Same type of question again here. Find the length of FJ. So X, then we just follow it down, 8X, 8 times 21. 21 times 8 is 168. Divide, and you get 21. One more of these. I think that's it for those. Find the length of QU. So there goes our X. Now go right down through 30 times 34. X times 33. 30 times 34. 1020. We write this as 33x. Divide the 1020 by 33. And nearest tenth necessary, so 30.90, so that doesn't bump the 9 up. 30.9. All right. Now on these, we switch to a different rule. The last one was 2 chords intersecting inside of a circle. Here, there are 2 secants. A secant is a line that goes through the circle and hits it twice. There are 2 secants intersecting outside the circle. Now, the way this works, the outside times the whole thing. Outside times the whole thing equals the outside times the whole thing. So for the top, outside is 8, but the whole thing would be 8 plus x. Then the other side, outside times the whole thing. Now you absolutely can just add and write it down like this again. You must add those to get the whole thing. Or if you just want to say that it's 4 plus 38, 4 is 38, that's fine. Either way, we'll distribute. We get 64 plus 8x. Then 4 times 38 is 152 minus 64, 88, divide by 8, 11. All right, again, outside times the whole thing. Now, the whole thing would be 6 plus 8, which you can write down, or 6 plus 8 is 14. So it's 6 times 14. And then the 4 is outside of the circle. The whole thing would be 4 plus x. Now, 6 times 14 is 84. Distribute 16 plus 4x. Then I'm going to subtract the 16. And then we'll divide by 4. 17. Again, outside times the whole thing. 6 plus 6 is 12. Outside times the whole thing. 6 times 12 is 72. Distribute, you get 9 plus 3x. Subtract 9. 72 minus 9, 63. Oops. Bring down your 3x. Divide by 3. 21. All right, now the last question here. We still have an outside times the whole thing. Oh, jeez. What's wrong with me? 2 is the outside, x plus 2. But now we have a tangent here instead of a secant that goes through it twice. So there's no outside and whole thing. You just, what you do is you square the tangent. Distribute 2x plus 4, and 6 times 6 is 36, minus the 4, divide by 2, 16. And then we go outside times the whole thing. The tangent, though, since there's no outside and whole thing, we just square it. So we distribute 9 plus 3x. 9 times 9 is 81. Subtract the 9, you got 72. And then divide 72 by 3, and you get 24. Oops, there we go. And the last one. So the x is over on the tangent, which is going to change this one a little bit. But we still got outside times the whole thing. 4 plus 21, 25. We square the tangent, so this is x squared. Now, 4 times 25 is 100. Now, with x squared equations, we either have to get one side to be 0 and factor, or you can just take the square root. This is one of the times when you can just take the square root because all you have is x squared and a number over here. So you can just take the square root because it cancels the square. But if you have x to the first anywhere, like another term, another like 4x or 7x or something, then you have to get the one side zeroing factor. But this time it's 10. Sorry about that. That should do it.